Okay, this problem wants us to answer some questions about the transformations without looking at the graph. I'm a big believer in graphing things and trying to figure things out. After a while, though, you will see that there is a pattern. So let's go ahead and just examine the pattern that we've seen. If you've done some graphing in the classroom and you've done some of the previous problems, you'll see that there is in fact a pattern. So let's write down what we see here. We have y is equal to, we have the number 3. And that 3 is in front of our absolute value. It's not inside, it's in front of the absolute value. And then we have x minus 2, which is on the inside of the absolute value. And then we have, let me see, hopefully this color shows up, a plus 4. Okay? So there is actually a certain pattern that you will see. I'm going to use function notation. They're not using it here. So f of x, which is the same thing as y, these are both exactly the same meaning. And I'm going to put, instead of the 3, I'm going to put a variable a, and then I'm going to have my absolute value of x minus h plus k. I've got all these pens here, and I'm getting lost on which pen is what. Okay, plus k. Okay, so each of those letters means something. So let's look at what each of those letters mean. Well, we examined in previous examples that when we have a letter in front of the absolute value, that A has to do with vertical stretch or compression. Vertical compression. Okay? And our H has to do with shifting left or right. And remember, the shift, this is always opposite. Opposite. Okay? So we examined that before when we were saying how far, what's our center? Our center is H. So when we put it on the number line, it's the opposite of what we see. Okay. And then the last letter on here is our letter K. So our letter K is our vertical shift, and that's up and down. Okay. There's one word I forgot to give you for H, and that's the word horizontal. Left and right is horizontal. I'm going to squeeze that up here. So that's our horizontal shift. Okay. So let's look at what we have with our numbers. So 3, let me just move this up. 3 is our, that's going to be either a stretch or a compression. Okay, it's vertical. It's a vertical stretch or compression. There is such a thing as a horizontal. Okay, so we have to decide, is it a stretch or is it a compression? So this is what I do. I look at the number 3 and I think of it as slope. So I think of that as 3 over 1. So that means I would go, if I were doing a slope, I would go 3 over 1 would be up 3, 1, 2, 3 over 1, which is much steeper than if I were just to do a slope of 1, which is what our parent function is, which is up 1 over 1. So you can see how our parent function wants to take that kind of slope. But this function wants to take a much steeper slope. So that's a stretch because the side is being stretched up. So this is a vertical stretch. Okay, so our 2, remember that's part of our vertex. So we do the opposite of what we see. So I'm going to write -2, that's what we see, means that we're going to go right 2, because it's opposite. And our +4 means we're going to go up 4. So that's all in comparison to our parent function. That's what it was asking us for, our parent function. We're at 0, 0 for the vertex of our parent function, and nothing else is going on. Everything is in comparison to that. Okay, so it also asks us for the axis of symmetry. So the axis of symmetry has to do with where, if I fold this in half, it would be the middle. We're going to cheat. We're going to look at the calculator. Okay, so on this calculator, I thought I had the lighting a little bit better on this. I'm hoping we'll be able to see this a little bit better. So I'm going to go to the y equals, there we go, it wasn't on. Let me clear what I have in there. So I'm going to go ahead and put in my function just as I see it. So I'm going to put in 3, and I'm going to put in the absolute value. So to get to the absolute value, I'm going to go to math, and then I'm going to scroll over to numbers. There's my absolute value. See, on this calculator it gives us those nice bars. I'm going to put x minus 2. Then I've got to scroll outside that absolute value, and I'm going to put in +4. So let's just see what that looks like. Okay, so that's what that looks like right there. So we can see that it went left 2 and up 4. Excuse me, right 2 and up 4, just like we said previously. So let's compare that to our parent function. So in y2, I'm going to put in absolute value. So I'm going to push the math button. I'm going to go to number, absolute value, and I'm just going to put in x. And I'm going to graph that. So we can see there's the parent function, and you can see that the function that we're interested in is much narrower than the parent. So the function we're interested in has been stretched. Now, we're talking about axis of symmetry. So axis of symmetry, let me go ahead and turn off the parent. I can go back to y2 on that equal sign and turn that box off by just pushing enter. Okay, so you see how this is no longer highlighted? So that means when I graph it, it's not going to show. So let's talk about the axis of symmetry. So if I take my ruler and I go to cut that right in the middle this way, that would be the line. If I could draw a line straight up and down, and I'm going to draw right on the front of my calculator. Hopefully that takes, sometimes it writes, sometimes it doesn't. You can kind of see that line there. That's right, that's the line x equals 2. So that would be my axis of symmetry. This vertical line is a line x equals 2. So that's what I'm going to write here, because the problem asks for the axis of symmetry. So my axis of symmetry is x equals 2. So we can also get that from right here, the opposite of that. It's my axis of symmetry.